We've had a number of requests to look at Ornith. Now, we've already looked at Ornith once before on this channel. Didn't go super well. And then Ornith, the bug magnet. Ornith needs a full rewrite of its math. Interesting. But to be fair, that was Ornith 1.0. There's a new Ornith in town, 1.5. This is a 35B A3B mixture of experts model. Let's download Ornith 1.5, put it through its paces, and see what it can do.
No place like local host. No place like local host.
Okay, the last time we looked at Ornith, we got it to try to produce a clone of the classic arcade game Asteroids for us, and it kind of got there. It produced something that worked. It failed code review. The code it generated was very sloppy, but it worked. I wasn't super impressed with it, but now Ornith 1.5 is here, and it claims to be much better and smarter than the original. They always make that claim. So let's put it to the test. We're not going to look at arcade games in this episode. Let's put that to one side for now. Let's look at something else. We're going to look at image processing. Here's an image of my bike. I really love this motorcycle, and I think the color blue on that is just beautiful. I really love it. But what would this bike look like if it were a different color? Can we selectively change the color of an object in a photograph and make it look realistic? I think we can. In fact, there's plenty of filters out there that do this. This is pretty much a solved problem in the field of image processing. In fact, I'd be amazed if any modern LLM hadn't been trained on code that solves this particular problem. So I expect this should be a pretty easy one, but I've been wrong before. Let's find out. Here's the idea. I've stood up a basic skeletal dialog that does this. You pick your source color by clicking on the image, and then you pick your target color. Let's say I want to see this bike in cherry red. And it does selective recoloring of the image to show you what the bike would look like with a different paint job. Now, there's many different approaches to this problem. The most naive approach would be to look for exact color matches. For example, if I select blue, 00255, and I say I want to replace it with red, 25500. The naive approach is just to go through the image, pixel by pixel, look for any value that matches exactly the color you're looking for, and then swap it to the color that you're targeting to replace it with. That's a terrible approach. And in fact, I've gone ahead and implemented that just to see what it looks like. If I left click here on the bike, you'll see that only like a little spray of paint there got changed. And if I pick different shades of blue by clicking on different pixels, it changes different parts of the bike, but why? I'm clicking on blue. Why isn't it replacing blue with red? Well, this is a full color image. Doing a straight and exact RGB color replacement, that would work on very low color images, like old 8-bit pixel graphics, for example, would be a good candidate for this approach. But a photograph has 24-bit color depth. That means you could have literally millions of different shades of blue. And by looking for an exact shade of a source color to change to an exact target color, you're going to hit very few pixels in that image. This is a very naive approach. So you could expand this approach. You could take the RGB values for each pixel, and you could say, well, okay, if it's plus or minus within a certain threshold, then I'm going to translate it to the equivalent color in the target color range. That's a little less naive, but it's still naive because the human eye doesn't perceive all three color bands the same way. You might have to bias it or weight those color bands. You have to do some fancy stuff. It gets kind of complex when you look at the color theory behind this. A proper formal approach would use hue and saturation to do some fancy math and figure out, okay, I need to sample not for an exact specific color, but for a range of colors in the source image, and then I have to translate and recolor into a range of colors in the output image. So we're going to see if the LLM can generate that for us, but I'm not going to tell it exactly how to do that. I'm just going to tell it what I want, and we're going to find out if the LLM is smart enough to make that happen. Now, as a baseline, I already went through this with Qwen 3.8, and Qwen 3.8 did a bang-up job. It took an hour, but it not only did a full color replacement, which we'll see at the end. I'll show you what Qwen came up with, and we'll compare it to what Ornith comes up with. But Qwen also went above and beyond, and it generated unit tests, because of course it did. Qwen 3.8 loves to test stuff. So I'm not going to specifically mention unit tests. I'm just going to point it in the general direction of the code and tell it what I want, and we'll see if Ornith can read my mind the same way that Qwen reads my mind. I kind of doubt it, but I've been wrong before. I'm perfectly willing to be pleasantly surprised in this episode. Let's see what happens. Now, I've downloaded two different versions of Ornith 1.5. I've downloaded the base model, and I've downloaded something called the Apex mix at iQuality. The iQuality Apex mix. This is one of those fancy remixes. We'll try them both and see if there's any difference between the two. The Apex mix claims to be smarter than the base model. We'll find out. We're going to start with the base model. So here's the settings I'm using. I downloaded this one at Q5. I'm going to use these settings from the Hugging Face model card, which I'm just going to bring up here real quick. Hugging Face model card looks like this. The recommended settings for general tasks: temperature 0.6, top P 0.95, top K 20. And in fact, that is exactly what I've got right here. I'm using full context because this model is actually not that big. The base model is 25 gigs. I guess that's kind of big, but I find that I can fit it easily into VRAM. So let's do that. Start up the base model and slide over to NV Top as it loads, and we see that it ends up using, even with the full size 262144 of context, it's only using 10.5 gigs on card 1 out of 12, 19.5 out of 24 on card 2. We're comfortably in VRAM, even with a full-size context window. That's pretty impressive. So if we slide over to OpenCode, we see our prompt. Ranger 1. This directory contains an extension for the image viewer application. The extension contributes a dialog that can do intelligent color replacement in a source image. Can you supply an implementation of the iColor replace interface? Oh, we didn't look at the code. We didn't look at the code. You know what? There's not much to look at. So it's pretty basic. I supplied an interface called iColor replace. It defines some strictness parameters without defining exactly what they do. I've got exact, strict, medium, and loose. And I give some general guidance in the Java docs that this is roughly related to how the algorithm is supposed to handle color matching. It has an on-complete handler that fires when it's done, and it's got one method to be implemented, and that is replace. It takes a source image, a source color, a target color, a strictness parameter, and an on-complete handler, and that's it. My example implementation I've called the naive color replacer, and it's exactly what it sounds like. All it does is iterate through the source image pixel by pixel and just look for an exact RGB match. This is a really naive implementation. If it finds one, it sets it to the target, but that's a really bad implementation, as we've seen. And I even say that in the Java docs. This is a deliberately naive implementation. This is just for example purposes, just so it has some idea of what I'm expecting of it. But if we go back to our prompt, I'm saying shades of the source color should be translated into shades of the destination color, depending on the strictness parameter. You may use whichever algorithm you feel is appropriate, RGB matching with a certain tolerance or HSV-based approach, whatever. I'm not telling it what to do. I also don't mention unit test in here. It's interesting to me to see if it just decides to do that. I also don't mention the README. I left it to do note in the README. Can we look at that real quick? So I left a note in here that this is not yet functional, it's a work in progress, and on the how do I use this section, I just have it to do. Usage notes go here. I'm not going to explicitly mention that. Qwen filled it in. As you might imagine, Qwen was very thorough. It went through the entire project. It's not a huge project. Qwen only used, I think, about 70 or 80,000 tokens of context, which is not much for Qwen. So if Qwen can do it with that degree of thoroughness, I would expect Ornith to do... You know what? I don't know what to expect. I don't know if Ornith is going to fill in the README, because I didn't mention it in my prompt, and I don't know if Ornith is going to fill in unit test for it, because I didn't mention that in my prompt. But Qwen did both, so that's the baseline I'm going with here. So let's put Ornith on the clock and see what it can do. Now, in my preliminary testing before filming, I was getting about 117 tokens per second out of this model, because it's an MOE model. They're naturally very fast, and it fits entirely into VRAM. So I'm expecting to get pretty good speed out of this thing, but you know, we'll see how it goes.
I cut the cloud from the center line, and every test comes back just fine.
7 minutes 52. Let's see what it did. Okay, interesting. It uses luminance sensitivity divided by the max possible distance to land. Okay, so that's not the same approach that Qwen took, but okay. Wired it into the dialog. It added tests, 5 tests, all passing. Okay. It noticed that the README is not filled in, but it left it alone since it explicitly wasn't. Okay, fair enough, since it wasn't part of the prompt. Okay, fair enough. All right, let's try it out. Okay, so if I pick a shade of blue and say strict matching, okay, it's kind of halfway there. No, see, if I go to medium, there's too much blue. If I go loose, it's going to change the whole... Yeah, okay, so it washes out the whole image. If I say I want a red bike... Yeah, no. So it almost gets there. It's like halfway there. But medium is too loose, and you start to see stuff in the background getting changed. So luminance, I think, is the wrong approach. Because there's nothing, I mean, I don't know why it's changing the sign and the mountain in the background. Okay, so not a great implementation, but it did write tests. I'm moderately impressed. It didn't pick the best possible approach here. Or maybe I picked a bad image. Let me pick another one. Here's a different picture of the same bike. Let me pick a color and change it to something else and say strict. Yeah, no, same deal. Same deal. It changes the background. It's too aggressive. It's way too aggressive. It's either just quite not aggressive enough or way too aggressive. There's nothing in between. Let me give it a chance to adjust. Okay, this is not a very helpful bug report, but I'm just going to complain that it's either not aggressive enough or too aggressive and see if Ornith can make sense out of that.
Spin it up, watch it fly close to home. You and I, if the net goes out tonight, I'm still right here, all right.
1136, that was interesting. That was genuinely interesting. Let me scroll up a little bit in the thinking data. Because I think my bug report was just terrible. I used the phrase tune it a little. Tune it a little is what I said. It considered rewriting its entire thing. Let me find this here. Yeah, okay, so, okay, look at this. It came up with something, that's more complex. Let me reconsider the scope. The user asked to tune it a little. I've already done this, so it was shying away from rewriting its entire approach because I said, let's tune it a little. That was such a dumb bug report on my part. But it was interesting to watch it. It thought really hard about that. Should I rewrite the whole thing and use an HSV hybrid approach, which, spoiler alert, is what Qwen did, or should I just try to tweak what I already have? So I think I think my bug report led it down a bad path. Let's see what we got. Okay, so I'm going to say, I click on the blue. That does, I mean, it's closer. It's closer. It's still not perfect. If I pick a different shade of blue, maybe. No, it still can't quite get there. It's closer than it was, but it's still not quite there. I think that's as close as you're going to get. So with this approach, I think that's as close as you're going to get. It's not terrible, but it's not great. Still, that is probably a prompting error. If I had said, let's rewrite it to be smarter, I think it might have pushed it down the right path. But I don't know. Is that the kind of thing that I should have to say? Okay, let's put a pin in that. I'm going to commit this, and I'm going to go back to the starting position. Okay, let's try that again with the Apex. Here's our settings for Apex. Now, if we look at the Hugging Face model card for Apex, there's actually not much here. In terms of suggested settings, they don't actually give you any. So I assume, because this is trained on top of the base model, I assume that the optimal settings are the same. So I just copied over what I used for the base model. Now this model does come with MTP, but in my testing before filming, I found that actually slows it down. There's an MTP head built into here, but it gives me a draft acceptance rate in my setup anyway of 0.3, which is so bad. It actually drops from 110 or so tokens per second down to about 90 tokens per second. So I'm just going to run it without MTP because that actually bumps it back up. So if we start up Ornith Apex and slide over to NV Top, as it loads, we see memory usage is about the same. 10.5 on card 1, just under 18 on card 2. Did I request a full context window? I did. So we're running a 262.144 context. So it's not actually using that much VRAM. So, okay, great. Okay, in open code now, I've switched to Ornith 1.5 35B A3B Apex I quality. I actually don't know what quantization level this is. It doesn't say on their model card page. I assume it's about Q5 because it's about the same size. And I've switched to a new branch. So we're going to start from the same starting position with the same prompt. I'm not going to suggest a specific algorithm. I'm just going to say implement an intelligent color replacement algorithm and go. And we'll see what Apex comes up with compared to the base model. Okay, well, I'm just gonna stop it. This is not going anywhere. So third attempt with Apex, it gets to a point where it just stops. It says it's thinking, and the GPU is doing something. And I can see it thinking hard about something on the server side, but it outputs nothing. This is my third attempt, same results. It gets to a certain point. Like, it does make tool calls. It explores the project and it starts thinking about the project, or about the problem statement. but then it just stops outputting stuff, and I don't know what it's doing, and it never comes back. This is the third attempt. So I'm calling it Apex is done. Either I've got the wrong settings for it, or there's just something wrong with this model, or it doesn't play nicely with open code, or it doesn't like my hardware, or something. Hell with it. I'm done with it. So I think what I'm going to do is go back to Ornith base, because we had some decent success. I think if I change my prompt a little bit, I'm going to go back to the starting position and change my prompt a little bit, maybe guide it in the right direction and see if it can get a better answer than what we saw. Okay, I've changed our prompt quite a bit. I feel like I'm leading the witness here, but I'm going to give it some hints from based on what Qwen did. So same prompt up until the last part here. Instead of saying you can pick whatever algorithm you want, I'm going to suggest an HSB-based approach measuring normalized deviations in HSB from the source color using an ellipsoid whose radii are measured by the requested strictness parameter. Recoloring can be done by matching saturation and brightness relative to the source color and transferring that to the target color. So dark red becomes dark blue, not flat blue, when the target color is blue, for example. I hope that makes sense to Ornith. And I've changed back to Ornith base model. We're in a new feature branch. We're not reusing the same Ornith branch. Actually, I'm using the Ornith Apex branch, but Apex didn't output any code, so it's fine. So, all right, go. Okay, 9 minutes, 9 seconds. I noticed some weirdness in the output. It didn't add tests, but I saw it running tests. I saw it running tests. Where did it? Oh, it wrote tests to the temp directory, ran them from there, and then discarded them. That's kind of weird. On its first pass, it actually took the time to add them into the project. I mean, it wrote tests, it passed the tests, it just didn't save them, which is kind of strange. But I guess, to be fair, I didn't tell it to. Okay, what do we got? If I pick the blue and say strict matching with red, nope. Not really. That's close. That's close. If you do loose matching, it gets most of it. It gets almost all of it. Okay, if I pick a better color. Yeah, look at that. Look at that. That's much better. That's in line with what I saw from Qwen. If I pick different colors now, like... That's actually close to the original color. Let's pick, I don't know, how about pink? Or purple. Yeah, okay. All right. What if I black it out? Nice. Nice. All right. Okay. So we got there. So I had to tell it exactly what to do. So maybe that's not a useful test compared to the first go around where I just left it up to the LLM to decide what to do, and it picked a suboptimal algorithm. This, when I told it, no, do what Qwen did, it came up with something much better. Let's go with... Look at that. Look at that. That's not bad. That's not bad. So it's changing the sign in the background. So, I mean, to do this properly, you'd want to be able to select a rectangular area of the image and say, just do your placement within this area, so it doesn't accidentally affect stuff in the background. But, I mean, for a first, for a one-shot deal, that's not terrible. Okay, as promised, here is the, here's what Qwen came up with. If I switch to medium, it's, I'd say, pretty equivalent to what we just saw from Ornith, which is maybe not surprising. I mean, you can see a little bit in the shadows. It gets a little too dark for it to consider that a match. If you go to loose matching, it fills that in reasonably well, but it has a stronger effect on the background. The street sign just changed to red. But you know what? Still not bad. I think they're pretty close, which is, I told it exactly what to do, so maybe not the best test, but there we go. Okay, let's do a code review of Ornith's first attempt, the one that didn't work so well. I'm going to take it to the Grizzle Senior Dev. I'm not going to use Copilot for this because I'm at the limit of my token usage for this month, so I'm going to use Qwen as my code reviewer. I'm just going to say, take a look at the intelligent color replace class. Is it a good algorithm? Is it well documented? Are there bugs or edge cases in it? And let's let Qwen think about that. Okay, 8 minutes, 18 seconds for that review. Qwen is not super fast, but let's see what it had to say. One of the more thoughtfully written color replacement algorithms I've seen. HSB space distance metric with the hue wraparound. Okay. Bugs alpha handling is not great. To be fair, I didn't tell it exactly how to handle the alpha channel. I'm actually okay with this because if you're dealing with JPEG images, they don't have an alpha channel, so who cares? Minor resource leak. Minor. Okay, the tests are solid but incomplete. Okay. Let's try that again on Ornith's second attempt. Okay, same prompt, same reviewer. Let's go. Okay, only 2 minutes for that review. Weird. Oh, that's because there were no tests. This was just the algorithm implementation. Okay, HSB ellipsoid approach is genuinely thoughtful. Shade preserving recolor math is the right idea. And the bulk row, okay. What do we got here? So performance problems. No null checks on anything. That's not good. I'm amazed that my code reviewer didn't nitpick the fact that there's no unit test for this class. All right, and just to keep things nice and even, let's do a code review of Qwen's code. Maybe a conflict of interest to have Qwen review its own work, but oh, let me switch branches. Let's see what it has to say. The author actually understands the math, but there's one subtle algorithmic bug and a couple of rough edges. What do we got? Not a showstopper. So okay, we're nitpicking, but I think I get the sense we're nitpicking here. It's not a blocker. Excellent class level Java docs. It's a master class. Okay, so it's very impressed at the Java docs. Yeah, okay, so look at this. It really went all out documenting this thing. It put a little table in there in line, described how the recoloring works, described known limitations. Yeah, okay, the whole class. Okay, so Qwen thinks Qwen did a good job. So which one do I merge? I think, not to pick on Ornith, I know it's probably unfair to put an MOE model up against Qwen 3.8 27B because nothing's going to beat that model at this point. But so obviously I'm going to merge Qwen, but Ornith, I think, did a reasonable job. You know, its first attempt, it wrote tests even though I didn't ask it to. Its second attempt, it didn't, which is weird, but the algorithm it chose was not optimal for my use case. The algorithm it wrote the first time around was maybe not great, but when I guided it a little bit, it nailed it. It came up with something that I think is probably equivalent to what Qwen came up with, and all I had to do was prompt it a little bit more strictly than the first time around. Instead of just saying, hey, you can pick whatever algorithm you want, I'm just going to suggest something which I know is the right answer because I've seen it work. So overall impressions of Ornith, the base model is not bad. For an MOE model, I'd say that's not bad. It did a reasonably good job. You might have to prompt it a little bit more specifically and guide it a little bit better than I did, especially on that first go around, but it'll get there. And it's fast. We were getting up to 117 tokens per second out of that model, which is great. Apex, it doesn't run for me. I don't know why. Maybe my lambda.cpp is out of date. Maybe I had the wrong config there. I don't know. I got nothing out of Apex, so I can't comment on it. But the base model of Ornith 1.5 35B A3B, the base model is solid. For an MOE, it's solid. It doesn't compare to Qwen 3.8, but nothing does. That's fine. So not bad. Ornith 1.5, I'd say, is a step up from Ornith 1.0. It's noticeably better in code quality. It got the job done. I don't know, maybe I'm nitpicking now, but I feel like Qwen 3.8, if I give it a vague prompt like choose your own algorithm, it's going to pick, I can trust it to pick the right algorithm. It'll just do it, and it did. I didn't mention unit tests, I didn't mention README updates. Qwen just did everything. Qwen took a look at the project and the surrounding context. It actually looked up the dependencies of the project and read them. And it took an hour, but it did a very thorough job. And, Qwen being Qwen, it wrote a bunch of tests. Yeah, so Qwen wins, but this wasn't really a battle episode. This isn't Ornith versus Qwen. This is just evaluating Ornith as a model in its own right. And I'd say, based on what I've seen, Ornith 1.5, 35B, A3B, seal of approval. It works. It's a good MOE model. If you can run it on your hardware at a reasonable speed, it's probably not a bad coding model. Okay, that's a wrap. Thank you for watching. If you want to support the channel, you could join, become a channel member, or hit me up on Patreon. I greatly appreciate it if you do that. Join our Discord. Note that the Discord link has changed. The original Discord invite link expired on me, so I had to generate a new one. I've made sure that this new link is set to never expire, so this is the actual invite link from now on to our public Discord. So join and come by and have a chat if you want, and thank you for watching. We'll see you next time. We've had a number of requests. Getting started is always the hardest part. 3, 2, 1. Come on, let's go. Okay, the last time we looked at Ornith, we got it to try to clone a clone of the clone of the clone of the clone. The Clone Wars. Begun the Clone Wars have. 3, 2, 1.